like that. It was straight up just like he probably had like 4 monsters the day before or something like that. He drinks like a ton of that stuff, so actually at the time I think it was Red Bull. He went outside, like he was to walk outside, and then I have no idea. I wasn't there for it. He told me about it. I was gonna say, I was like, it's the best place too. Besides the hospital, that's probably one of the best places.
All right, guys, let's take a look at this. It's nothing too crazy yet. The first problem seems a lot more detailed than it really is. What do you guys think about the sample? It's just kind of like staring you in the face. What was the sample? There's a few different ways you can answer this question. There's a very kind of like concise way to answer this. What was the sample? What have you guys been doing?
Would that be the number of people that were actually?
Yeah. So the sample is the group of people and things that we actually analyze or talk to. So one way to answer this is, I think one group did this. They just added it all up. Now what I'm curious about is you get a number, but how did you describe it? If you add all those up, how many total people were in my sample?
261.
261. How do you describe them? 261 people from the world?
Ecuador.
From Ecuador. I love it. Don't say 261 drinkers, because were they all drinkers? No. So 261 Ecuadorians, I think is how you say it. Anybody from Ecuador? Ecuadorians, I believe, or people from Ecuador, is fine. Ecuadorians? Oh my goodness. Okay. So then, the minute you know, here's the funny thing about this. If you know the sample, you cannot help but know the population. Because you almost always can just take the number and replace it with the word all. So in general, if you know the sample, you just think, where did they pick those from? So could the population be everybody on Earth?
Yes.
Would it make sense? Let me say this, you're right, it could be. But does it make sense to say the population is everybody on Earth? No, because how do you end up with 261 people from Ecuador if you were allowing everybody from Earth to be picked? That would be incredibly unlikely. So more likely the population is just all Ecuadorians. Okay. Oh boy, let's have an adventure with this word again. Here we go. Now, anybody understand? I had a little discussion with one group, but did anybody come up with something good for Part B, do you think? Why might they have broken the population up the way they did? I think we talked about last time about breaking the population up to pick a better sample.
We just like to see the correlation between getting stomach cancer and how much you drink.
True, and why would they specifically want to divvy it up at least some way that they did?
Because it's around the same amount of people per group.
Okay, good. They have kind of a roughly equal representation from each group, but why break it up into groups in the first place? Yes?
Heavy drinkers might react differently to drinking than someone who doesn't drink.
Exactly. And if I don't break my population up into groups first, is it possible I pick a random sample and not get anyone that doesn't drink? You understand? If I just if I just have it be all Ecuadorians and just randomly pick Ecuadorians, could I possibly end up with a sample where everybody drinks? Yes. And that wouldn't really get me what I need. Now, don't freak out. Okay. This problem I wanted just to get a little bit deeper with the idea of why would I pick a way to pick a sample? I need people who don't drink, and I need people who do drink different amounts so I can see the differences. So that's a beautiful time you break it up and make sure you take people from every group you need. Yes? Instead of just hoping. Let's hope the sample comes out good. No. How do I wrap that up here? To get the data they need to see differences. Blah, blah, blah. And then I gave you number 2, which was a little bit evil, but I just want you to be aware quickly that I am evil. Let me do this for myself. So I said you should use another piece of paper. So obviously the stems, what's the lowest stem it looks like? 1. And then it goes 2, 3, 4. What's the biggest stem? 6. And I think 1 has only got 1, right? So what do you guys get for 1? You got 8. For 2s you got 2, 7, 9. For 3s you got 2, 3, 8. For 4s you got 2, 3, 3, 6. For 5s, for 50s you got. So 1, 2. 1, 2. 1, 2. 6, 7. Okay. And then for 6s you got 0, 5. You guys all with me? Okay. Now, of course, somebody pointed out that was a little evil because Part B says go do this stuff. And you're like, holy shit, I didn't leave any room. Somebody was asking me in the event you do that, and you could kind of continue it this way, but you see how visually it's not quite as good? But if it's my fault for not prepping you, that's fine. So now I could just, for the other set of data, I could just put it along here. Oh, what's missing, by the way? Why is this not a good answer yet? Key, good. The book does not make a deal out of the key at all, but I hope some of you guys understand the key is almost the most important thing. So you just pick anything you want to here and just say how to read it. Okay. And now you just put the other data going the other way. So this is all very exciting. So let me see. What is it? Whoa. 8, 8. Is that look good so far? Oh, I left the 7 out? Way to go, Jeff. 7, 9, 9. 9?
No.
9! Okay.
1, 9.
1, 9?
Yeah.
Okay.
No, there's
2 9s! Okay, I love you guys. Okay. And then 20s. Let's see, there's 20. What else we got?
1, 2, 4, 5, 6.
Okay. And then 30s.
2,
2. And then 40s.
3, 6,
3, 6. And then 50s.
7, and 8.
And then 60s.
9.
What is it, sorry?
9.
None! 9. Okay. And then you can very quickly see throughout the day, and this is something that Starbucks would kind of like want to do because they could gear certain things at certain times of the day for different age groups, possibly is one way they can do their marketing. You can see on the left, on the right side, it's a certain distribution. On the left side looks more skewed. And why do you think that might be? Especially for like a Starbucks like around the corner there. Because a lot of college students are younger, and their first class is probably not 6. Right? And a lot of older folks, I don't know, have you guys been to like a coffee shop? If you don't go to Starbucks, I understand. Coffee shop. I always love to go to the coffee shop. These old guys, and I know I'm getting there myself. I am there. I'm going to be in there with a newspaper with a friend of mine just arguing about reading what's in the newspaper. So you get a lot of, early in the morning, they want to go out there and get their blood going, so they want to complain about stuff. I understand that. It's a lot to complain about. Is that right? So that's not too bad. Stem and leaf plots are beautiful. You should enjoy the hell out of them. Number 3, I kind of left a couple things up for you guys to interpret from context. How many people were in this first group? 11, so then you figure out how many people total were there. 20, okay, so you just add up all the groups that had people in them. Then the next thing I ask people, and I don't blame you for this, you're not sure what to count or not, but the minute I ask you how many empty classes are there, then you saw, okay, they are classes, they're just empty. So how many total classes were there? 6. And this one I left up to interpretation, but this is not too bad. How wide is each class? 20. 20 weeks, I love it, kick ass, even some units in there. And then the last one, and again, don't read too much into this and don't make assumptions about Piana. This is, you're not gonna believe this, but I made this up. At least 40 weeks. A lot of people have trouble with at least. Our brain thinks least less, and we go the wrong way. So if you have to be at least this tall to ride the ride, here's Jeff. I remember when we went to, I was so excited. Young Jeff, we're going to Disney World Atlantic, you remember? I was so excited for this one thing, and I get there, and and the next time we went, that ride was shut down. I think it was a treehouse thing or something, and I just wasn't tall enough. So if you have to be at least this tall to ride the ride, you have to be that tall or more. And one little thing I'm glad that somebody noticed, when you have histograms, the lower, the 40, for example, is assumed to be in the class after, like this way for you guys, right? So that starts at 40, goes to 50, almost. The class before goes from 20 to almost 40. I don't know if you guys are with me. So that's a little bit of a detail, but that's a good point. So how many people had it last at least 40 weeks?
33,
Out of,
20,
and when that would be?
15%.
Kick ass. Okay. So not too bad, not too bad. Section 10.1, pretty straightforward. A lot of it you've seen before, some of it you never created, but you can maybe see how to create it. Okay. Oh, I gotta turn you back on. Damn it. Is there any questions from that worksheet? All right, we're gonna get a little more technical now. Oh shit, which one was it I wanted? You? Yes. Okay. All right, so now we're gonna get into the analysis part. And we already did a little bit of this on the first day. I know you all know how to calculate average. That's why I wanted to do that on the first day. So 10.2 is all about analysis of data. So what we start with, all right, if I have a giant collection of data, 800 data points, yes? Let's say I have 800 data points and they represent the SAT scores for people that went through Kaplan. Have you guys heard of Kaplan? Anyway, it's a thing that's supposed to help you increase your SAT score. So I have 800 data SAT scores. What is one really good analysis I can do very quickly to tell somebody one number that will help them understand all the data? What's one thing I can calculate? If I have 800 SAT scores and I want to kind of summarize it for somebody, I can give them one number.
Average.
The average, that kind of makes sense. You with me? All right, so the average, and what's the average try to measure? This actually came up last time. It's trying to measure about where the what is. Where the what is. I asked, remember when I asked you, if you have a data set 2, 5, 6, 10, 11, and you think the average is 12, well, that's obviously wrong because the average should be in the middle sort of somewhere, yes? You guys kind of with me? Now obviously, real quick, have you guys ever been to La Jolla?
Yes.
Have you ever walked around in La Jolla and said, that's a really nice house that I'll never even be invited into? So,
Or be able to afford.
exactly. So when they report housing prices, if you've ever paid attention to it, they do not report the average. Why do you think that is? If they reported the average, yeah?
The outliers would change it so much. Like,
Yeah.
like median.
Because you have all these outliers that are way the shit up there. So if I tell you the average, it doesn't really give you an idea of the majority. That average would not really be in the middle, would it? I have a lot of these little houses that don't cost much, and then over here I got, well, from your perspective, over here I've got houses that cost an insane amount. So they drag the average up. It's not really the middle, but it still is trying to tell where the middle is. So the average is the most commonly used way to get the center of the data. And we have more than that, because like I just told you, sometimes it sucks. Sometimes it does a bad job. And I think this book, yes, sweet. So what we colloquially call the average, in mathematics we call it the mean. So have you ever heard the average referred to as the mean? Okay. Math people like that because it's a 4-letter word that starts with M. So we're all about it. Okay. So, for example, let's say I'm gonna start working at this little company, and there's 4 people that work there, 3 employees and a CEO, yes? And I ask, you know, and the reality is, one guy makes 30,000 a year, somebody makes 40,000 a year, somebody else makes 42,000 a year, and the CEO makes 350,000 a year. If I ask them, hey, how much could I expect to make if I work there, and they tell me the average, is that an accurate representation of how much I can expect to make there when I start working there? They killed me. What would the average be? Can somebody calculate that very semi-quickly? This is in thousands, by the way, right? Not $30 a year. Oh shit, I just added them up, I forgot.
115.5.
Thank you. So $115,500 would be the average. Or the mean. I should start using that word. So if they report that to me as the amount of money I can expect to make, that's very wrong. Now statistically, that's an accurate way to measure the center. That's a way to measure it. Well, what would be a better number to tell somebody? A single number. Does anyone know there's something better than the average? Now, why is that average so skewed?
Because the one guy makes a lot more.
Because there's one data point, like Gabriel said, is an outlier. There's one person that makes way more. Yes? There is a better way to measure the center, which is actually the physical center. Yes?
I don't know what it's called, where you line it up when it's in the middle and then you cross off.
Okay, cool. Yeah, you kind of cross out until you get to the middle.
Is it median?
The median, kick ass. So like in the middle of the road is the median, yes? And some of us have maybe driven over that sometimes, late at night, potentially, or, yeah, okay. So, is there a number that is in the middle of this data? Is 40 in the middle?
40 middle
Yeah, so if I have if I have an odd number of things, let me do this without flipping you guys off. Isn't there a number that's in the middle, if they're in order? If I have an even number of things, there's 2 things in the middle. So then how do I get the middle? I average the 2 that's in the middle. Now that's freaking middle, yes? Or that's mid. So what's the average of the 2 numbers in the middle? 41. We call that the median. Would that median change if the CEO got a pay raise and went up to $700,000? Would the median change?
No.
Would the average change?
Yes.
Hell yeah, okay. So the median is not affected by outliers. So when you have reports about income and you have reports about housing prices, you almost always see median because it makes more sense. But the average kind of wins out in general. It's normally the best thing. Because what does the average do that the median doesn't? The average considers all the data points. The median just cares about the middle data points. If you're taking staff before, I'm sorry, this is all very basic shit. And then there's one last thing now real quick. What kind of data? So I got numerical, non-numerical. Could I calculate the average for hair colors? No. Could I calculate the median for hair colors? Is there any order that hair colors have to be in? So I couldn't figure out the median hair colors. What are you doing? So, do I always have numerical data? No. I sometimes have what's qualitative, which is non-numerical data. But I still want to know how to figure out where the data seems to be clustering or where the middle is. So we have another form for figuring out the center that works for data that's not numerical, and it's called the mode.
Most often.
Yes, good. Whenever I see this, I always think about pie a la mode, pie with ice cream.
I just
So I want the most ice cream, yes.
I just think mode.
Mode?
Starts with the MO most often.
Most, exactly. Mode, most. So, for example, is there a mode in this data? Is there any number that occurs the most?
No.
No, so this would be no mode. What about this data here? Oh my God, Jeff, is there a mode? Holy shit, what's the mode? 2, that's insane. What about this data? 1, 2, 2, 5, 17, 17. Is there a mode? No, are there 2 modes?
Yeah.
Yeah, so this is bimodal. So the mode is a very strange form of the center. It's more interested in where the data is clustering. It's sort of related to dot plots, because it's all about repeats, yes? But just to be really careful, what's the mode? I'm sorry, I'm zooming up here really quickly, but hopefully you guys are with me. 1, 2, 2, 5, 5, 5, 17. What's the mode there? 5. There's a clear winner. Okay, and we don't, some books go to trimodal, but I mean, anything above bimodal, you're just like, there's no mode. It goes 1, 1, 2, 2, 3, 3, 4, 4, 5. No, there's no freaking mode. There's no winner. You guys see what I'm saying? Okay. Nobody shines. Poor little set of data. How you guys doing? I know everybody's heard about average. Now you know it's called mean. You all have heard about the median. Mode, maybe not so much, but mode's freaking nice and easy. Yes. And for non-qualitative, or non-numerical data, if I said there were, if I counted the cars out there, and I saw 7 Fords, and I saw 8 Chevys, Jeff, and I saw 11 Hyundais, sorry, what would be the modal class of car? What would be the modal class of car? Hyundai, because it's, or Hyundai, I don't know. Hyundai, because that's the one that occurred the most. So this does work for non-numerical data. Now, of course, you have to count them and stuff. Okay, maybe, not too bad. Mean, median, mode, beautiful. Okay. I love this, you're doing great. Now we're gonna get into something a little bit weirder. All right, how many guys have taken an SAT test? Anybody? You taken it? Okay. What were your subjects?
Actually, pretty good.
Yeah?
I decided like the day before I was gonna take it.
And it went well?
Yeah.
Do you know, so when I was younger, they would have a certain day to take it. You'd go take it. Do they give the same test every time?
I don't think so.
Why wouldn't they? Why would it not make any sense to do that?
Because then people would post the answer, or.
I would send my friend, you go this Saturday, you come back, tell me everything, and I'll go the next Saturday. So of course they change it every time, yes? Is it possible that when they change it, they kind of arbitrarily make it a little bit harder? Is that possible? You guys with me? I mean, if the minute you change a test, is it possible you made it easier or harder than it was? Of course, yes? So that's why a pure number, I know they still report like 1600 or whatever. Even that's sort of like standardized, but I don't want to get too deep into that. You want a way to do a relative score. So if a lot of people all take a really hard test, a 40 could be a really good grade. No. My first test in grad school, I got a 19 out of 40 on my, it was a little quiz. And I was like, what am I doing here? I'm in the wrong place. And the teacher came by and said, good job, Jeff. And I'm like, you're a dick. What? I thought he was being an asshole. But no, the average on the freaking thing was like a 15 out of 40 or something. You guys kind of with me? So the absolute grade I made sucked, but the relative grade I made was okay. You guys kind of with me? Okay, really true. So there's an idea called a percentile. By the way, well, no, I guess I'll keep it on. Can you guys all see okay? I'm sorry, I dimmed it because I can't make this light turn off. All right. Has anyone ever heard of percentiles? You're in the 50th percentile. So if you have any kids, very often you'll know your child is in the 80th percentile for height and the 50th percentile for weight, right? Does anybody have any children? I don't want to get too personal, but if you have any kids, so you might, what's happening in the corner?
Siri,
Oh,
just stop.
stop.
I found this on the web.
Oh. What's, oh,
Sometimes
what do I tell it?
just click the screen.
Siri, go away.
Okay.
Oh, we all get to experience that. Okay. What was I just saying? Shit. Oh. If you have kids, you might have seen a picture like this before. For like height. And so you can see your kid maybe is in the 90th percentile for height and maybe in the 40th percentile for weight. So kind of tall and skinny. What are you guys kind of with me? So like the middle dotted line is the average, and then I see how far away from that I get, and the relative to other kids at that age. Yes? So it's a relative score. Okay. So if I go to some other country and I'm like, oh, that guy's tall, maybe everybody there is taller on average, and that guy is actually relatively normal. You guys kind of with me? Okay. So let me ask you this. Let me see. Where am I at? Oh, good. Good. Okay, let me get there. Let me make up some data here, and then I want to ask you a very unfair question. This is the Watch Jeff Make Up Data class. I'm going to put this in order because I'm nice to myself. Ha ha ha.
And us.
No, I'm apparently not nice to you guys. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Can somebody give me an idea? Which number do you, and again, I told you this is an unfair question, but let me see what you guys say. What do you think the number is that is in the 80th percentile? And what a percentile means. If you're in the 80th percentile intelligence, is that a good place to be relatively? Does anyone know what that means? And by the way, IQ tests are shit, but I don't know, it's the first thing that came to mind. 80th percentile height. Let's say you're in the 80th percentile height. What does that mean? Does anyone know what that means? Taller than 80%. So any percentile is very single-minded. It always means this percentage is below that. So if you made in the 20th percentile on a test, does that mean you failed?
No.
20th percentile on a test, did you fail?
Not necessarily.
Could you have gotten a 90?
Yeah.
Hell yeah, because maybe like 80% of people got above a 90. You could be in the 20th percentile at a 90. You guys with me? Okay. So percentile isn't absolute, it's relative. Does that make sense? Your absolute grade could be 90, your relative grade could be shit. Just like my absolute grade sucked, well, my relative grade is pretty good. Okay. Anybody have a guess as to what the, what did I say, 80th percentile might be?
18.
So I have one guess for the 80th percentile is, one guess is 18. Say again, 20? So what's your reasoning for 18? Because it's the, what's the reasoning for 18?
It's not the middle, but it's more closer to like.
Oh, okay, so you did it more visual.
Yeah.
You're like the middle would be about 50, so only go a little bit up. I love it, okay. What's the idea behind 20? It's the 8th number in. That's beautiful logic. Any other guesses? 21 is another guess. What's your reasoning for that?
Because there's like, you are at the 80%, so you go.
I love it. So percentile is supposed to mean that percentage is below it. So if I have 10 numbers, bless you, how many numbers should be below it if I'm in the 80th percentile? What's 80% of 10? 8. So there should be 8 numbers below it. So 21 makes sense. Now, of course, this is where Jeff is an asshole and says all of those are wrong, but the logic is there. I love it. There's a visual, there's an idea about it was the 8th, and there's the idea about it's got 8 below. Now, if I'm in the 80th percentile, what percentage should be above me? 20. So this would make sense because there's 20% above it, but there's only 70% below it. So very quickly, if I want to calculate the median, what percentile would that be? The median is the number that's halfway. If I have 4 data points, are any of the data points the 50th percentile, or any of the data points the median? No. The average of the two in the middle is the median, yes? Okay, I'm sorry, I'm throwing a lot at you. The median is also known as the 50th percentile, because it's right in the middle, it's got 50% above it, 50% below it. But it is not one of the data points in certain situations. So right now, none of those data points are the 80th percentile. Because none of them have 8 data points below and 2 above. You guys kind of. So what is 80% of 10? I'm 10. What's 80% of 10? So what you do is you count in 1, 2, 3, 4, 5, 6, 7, 8. So if you take 80% of 10 and you get a whole number, you average that with the next one. What is half of 4?
2.
Holy shit. Is that the median? No, so if you get a whole number, you average that one with the next one. Then that would be the actual percentile. So my 80th percentile,
20.5.
yes, which I represent like this. I don't think the book does this, but I just want to show you. 80th percentile is 20 plus 21 divided by 2 is average those, 20.5. So all of you got close. But if I want to get really specific, the 80th percentile has that 80% below it, 20% above it. So that's the best. Okay, I like it. Of course, I cheated because I'm a math guy. I do this all the time, so I know this shit. It's okay. Does that make sense? It does jive with our idea of median. Median is just a type of percentile. It's totally the same idea. Okay. So, can you guys take a moment and figure out what the 25th percentile is for that data? Go ahead. What's the 25th percentile? There's 2 steps, yes? The first step is 25% of 10, and the second step is go get the answer. Now, real quick, I'm being really mean right now. Let me change that my request. Figure out what the 50th percentile is. Do that, sorry. Figure out what the 50th percentile is. And somebody remind me, what's another name for the 50th percentile? Median. So somebody said, kind of cross out and go, you'll get to the middle. And of course, with 10 numbers, there's no middle number, so we already know how to handle that. So what is 50% of 10? 5. Why are you so strong? Okay. So we go 1, 2, 3, 4, 5. I want to average the 5th and the 6th. So whenever I get a whole number for my percentage work, I average that one with the next one. 13.5. So P50 is 13.5. Now, what is P25? Well, what's 25% of 10? Yeah, real quick. Bless you. There's a hard way to do that and there's an easy way to do that. 25% is 1/4, 1/4 of 10, holy shit. A little bit rough. But 25% of 10 is 25% times 10. 0.25 times 10, you smooth the decimal once, 2.5. And of course, some of you guys are like, I have this thing called a calculator. Great. So that's 2.5. Is that a whole number? Is that a whole number? 2.5? Nope. So when you get a whole number, you average that with the next one. If you get anything else, any decimal, you round it up. Round that up to 3. What's the third number? 7. So P25 is 7. So it's almost nice to get a decimal answer. So if it was 2.1, I would round it up to 3. You just always round it up. So there's only 2 things that can happen. You take a percentage and you get a whole number, so you average it, or you take a percentage and you get a decimal, and then you round it up. You guys with me? Every percentile has 2 steps. First step is take the percentage. Second step is go get the answer. The first step just tells you where the answer is. I love you guys. So real quick, I want to show you a little shortcut, but I'm going to make you do it the long way first. Why would I do P75? Stay with me now. I understand. I'm a math guy. I'm used to being the most exciting guy in the room. It's okay. What's the first step for figuring out P75? 75% of 10, which now you guys know is 7.5, round it up to 8. What's the 8th number? 20. Let me show you a shortcut. How far into the list did I have to go for P25? 3 steps, yes? So if I start at the bottom and go 1, 2, 3, I get P25. If I start at the top and go 1, 2, 3, I get P75 because they're symmetric. 25% in from the bottom, 25% in from the top. I can get P25, P75. Okay. You're all very excited about that, I know. So let me capture what we just did. You guys can help me out a little bit. Let me see. You guys all have these numbers here for me? Okay. What was P? Get over here. P25? Do it again, sorry. 7?
Yeah.
What was P50?
13.5.
13.5. What was P75? 20. What was the lowest data point?
2.
2. And what was the highest data point? 27. Okay. How many numbers did I just write down? 5. You're gonna love this shit. So never forget this, kids. Math people, we're so creative. We're brimming with creativity. Do you all agree that this summarizes my data in a way? Kind of tells me what the middle seems to be, and it tells me kind of like how spread out it is.
Yeah.
So we call this the 5-number summary. We are just amazing people. We're gonna create. By the way, there's a lot of me talking at the end of today. Next time we're gonna have a worksheet that does some of this stuff. Yes, so you can actually get hands on. We're gonna create a visual. I don't wanna show you what it looks like yet, because when we get it done, I wanna see how many people recognize it. Some of you guys know where I'm going with this, don't say anything. I want to scale on my number line so I can capture all the numbers I just wrote down. So can somebody give me an idea where I should start? So I could start at 2, that's fine. So let's start at 2. And I want to include 27, I guess. I could have started at 0, that would have been fine. In fact, let's do that. Let's go crazy, everybody. This is the math guy's idea of going crazy. I want to get up to like maybe 30. I want every number to have a place to go. So what scale could I use to go from 0 to 30? I don't want to use scale of 1, screw that. 5s, I love it. 5, 10, 15, 20, 25, 30, okay. You don't have to say it like that if you do it. Don't say it. I think some of you guys have seen this before. What I'm going to do, I'm not going to put a point. I'm not going to plot points. I'm going to put a line above each data value. So above 2, which is roughly here, I'm going to put a line. Do you guys see that? About where 2 is, I'm going to put a line. 2.5 would be in the middle, so I went a little back. 7 would be about here. 13.5, holy shit. 13.5 would be about here. And then 20 is a nice one, thank you 20, you're the real MVP. And then 27 is about here. So you got these 5 little lines just floating up there, and you're like, good job, Jeff, it's amazing. Does anyone know where I'm going?
Yeah.
Okay, so we guys, I love it. So what I want you to do now is see the middle 3 lines? Make a little box.
Oh.
There we go. And then see the outer lines, just make whiskers. I can't remember this book calls this what it should.
Whisker flower.
Yeah, it's a box and whisker plot. It's also called a box plot, which is really exciting. It's like a circle graph and a box plot. So this is a box and whisker because it's freaking got a box and it's got whiskers. Have you guys seen this kind of graph before? I'm almost certain you have.
Yeah.
So this is used in education a ton. Box and whisker, because I could have several box and whiskers that represent different classes, different schools, different whatever, and I can quickly see which schools seem to be performing better, which schools are more consistent, which schools have a bigger spread, which schools have more students here or there, right? Very quick visual. Okay. And it's really simple to create. That wasn't a lot of work to get those 5 numbers, and there you draw freaking lines. Yes, maybe. Is it possible that some of these could be repetitious? Like, could P25 be the same thing as P50? Could somebody, I really want you to think about this for a second. Could any of those be equal to any of the other ones? Yes, and all I would need is data like 1, 2, 7, 7, 7, 7, 7, 7, 7, 7, 8. Okay. So, do you see how P25? I can just say this. P25 equals P50 equals P75 is freaking 7. You guys see what I mean? So it's not hard to have some that repeat. So your picture could look very different. Your picture could possibly look something like this. It could look like this. Look at me. Let me show you. That's funny. Part of my brain was like, I should show them. That just means that P25, P50, P75 are all the same. So I just swoosh. Can anyone tell me what percentage of data is in the box? What's in the box? What's the box? What percentage of the data is in that box? What was this again? P what? P75. What's this? What percentage is below P75? 75%. What percentage is below P25? If this is 75% and this is 25%, there must be good. So the box in the box and whisker plot is the heartland of the data. It's the middle 50%. Yes? So very often if you look at a college, they'll report the middle 50% SAT scores, the middle 50% incoming GPAs, whatever. Then you got your over and your underachievers down there. Okay. Oh my God. Okay. Oh, it's over there. So little time. Oh, okay. So I'm gonna be able to just barely get into this idea. So please let percentiles, box and whisker plots, they're relatively easy. There's not a lot of math that goes into them. They're awesome. I hope you agree. We'll see. Oh, before I forget, there is one little thing. Shoot. Okay, you guys help me out. There's something called the interquartile range. Oh my God. And the box seems to be like a thing they like to report directly. So the interquartile range, oh, and I forgot something else. So instead of putting P25, P50, P75, if I'm 25% of the way through a basketball game, and even if you don't watch basketball, you guys know there's 4 quarters. If I'm 25% of the way in, how many quarters have gone by? One. So I could call this quarter 1. I could call this quarter 2. I can call, and these are called, remarkably enough, they're called quartiles. You guys got it with me? And that's why this is talking about the interquartile range, or the interquartile range. So this is just Q3 minus Q1. That's all that is. Okay. So it just kind of tells you the box in your picture, how wide is it going to be? What range of data does your middle 50% cover? Yes? So what would the interquartile range be for this picture? What would the IQR be there? How wide is the box part? 0. Remember that one was where Q1 equal to Q2 equal to Q3? That's why it's all smushed. What's the interquartile range for this one? No, it's Q3 minus Q1. 13. And it just is how wide is the box. That's all it is. Okay. Guys. No, so I'm going to do one little thing. I'm going to have to leave this for next time. If I gave you a set of data like this, and I gave you another set of data like this, oh shoot, let me make it different. Hold on. I'm trying to do this on the fly. I'm trying to do it live, kids. Go away. All right. Yeah, let's do this. Okay. That's better. Now, do they have their averages for each set of data? So this is data 1, this is data 2, yes? The first set of data, second set of data, what's the average? Is it different?
No.
They both have an average of 3. You with me? but are they spread out the same amount? Which one's more spread out? And the word spread has a very specific meaning in statistics, but let me see what you guys say. This one's a little bit obvious. I made it kind of obvious just to get to the point. Which one's more spread out? X2. So in statistics, we consider the word spread to mean which one gets further away from its mean on average. So the first data point, 3 people stayed home and 2 people left. You see that? If I call the mean home, it's like the parents are like, get the hell out of here. Like, no. Data 2, 1 person stayed home and everybody else left, so it's more spread out. Yes, more people are further from the mean in the second data set. You guys kind of follow. So a little teaser, next time we're gonna calculate whatever the number is that we calculate for the spread, it will be smaller for this set of data than it will be for that set of data, because it measures how spread out the data is. So next time we'll do that, and then I'll give you a little handout to work on. Then we'll get into chapter 11. Yeah. Okay, that's enough for now. So, also next time we'll talk about our first quiz. I'm thinking our first quiz will be next Thursday, huh? I'm sorry, the first quiz is the double quiz, so it's set. I forget what day I put it, but you, thank you. So it's set. All right, guys, I'll see you next week. If you have a question, come on up. No, you can keep those, yeah. Thank you.